Welcome to this tutorial. Today I give you a basic introduction to the APPH GUI and show you how to perform a simple phase noise measurement. I have already pre-installed the APPH GUI, so let's just start it up. I also have already connected my APPH to the local area network. So you can see it up here, it's this APPH 6040. There are also other devices connected currently. We will work with the top one. Let's select it and it will automatically connect. Let's have a look at our options. You see that the APPH already detected the signal at 1.005 GHz. It's one of our signal generators that I have connected up to the APPH. We have a question mark button over here, which can be quite helpful. It shows us the connectivity schematic of the currently selected measurement. Now in this case it's a very easy setup. We just have our DUT and we connect it directly to the DUT port of the APPH. But if you have external references or an additive phase noise setup, that might be a little bit more complicated, and this connectivity schematic can be quite helpful. On the next line we can choose our offset range of the measurement. So I've chosen a range from 10 Hz to 50 MHz. And then we have those three buttons, which can be used to first select whether we use internal or external references, which is this button here on the left. Then we can choose the number of correlations and averages. So let's just change that for now, because I want to have 5 correlations. And on the right side we can select our internal supplies, which can be used to power TUTs with the APPH itself. We're not going to use them today because I have a signal generator which is already powered. And the last thing we can do here is just press on the measure button here, which will start the measurement itself. So we have already our first correlation, and you can see the correlations are coming in. We are currently at correlation 5 and we're finished now. So this is our first measurement. Let's just add it to our list of traces here so we can work with it. So we do that by pressing the add button. You see the color changed and it moved into this list here. Now let's see what our values are. We can either just look at the plot here, or we can add markers. We have a marker list here which is currently empty, so add some markers by just pressing on the new button. Then we can move around on the plot and click if we have the marker at the desired location. So let's just add some markers here, like this. Now let's do a second measurement with some more correlations here to see a difference between different correlations, because you can see that the plot itself is quite smooth up here, but it has a lot of variance in the closer offset ranges. You can see that if we do multiple correlations, this trace moves out here quite a lot. So I think that's already enough. So let's stop the measurement and add the trace as well. So we have 2 traces here, a green one and a blue one. Now you can see when we are moving over them that we can have some more information about the trace itself. So this trace was done with 5 correlations, this trace was done with 19 correlations. We can rename the traces. We can disable them or enable them, which will just show or not show them in the plot down here. And we can change the color by just clicking on the rectangle here. So for instance, with this blue trace, we can change the color a bit. Then we can obviously delete certain traces by just pressing the delete button here. What we can also do is edit to have more information shown about the plot. For instance, we can show the detected spurs that were detected during the measurement and removed from the curve. We can also filter them based on a threshold. We can smooth the curve by just selecting a smoothing aperture. And we can shift the trace, which helps you compare the trace to a different duty at a different frequency, for instance. And we can also show the relative phase noise. Now this is maybe interesting. Let's do another measurement with a few correlations here. You can see this gray relative phase noise. Here, this shows us the measurement noise floor itself, and we see that the measurement noise floor moves away from the trace itself, so this indicates to us that by further correlating we cannot improve the phase noise value of our measurement. We will just smooth the curve a little bit more. And if the curve itself moves down with the noise floor, then this indicates to us that by further correlating we can still improve the phase noise value. Okay, then we have the general plot settings button over here, which will open this plots dialog. So we can do several things here. We can give the plot a title. We can show a legend of all the currently shown traces, which are our two traces here. We can show a list of all markers on the right side here. This will just show us the values of the selected curve. So if we select this curve, you can see we have the corresponding dBc values, dBc per Hertz values of that curve. We can do the same with the spurs. No spur is currently shown, but if we select the spurs to be shown here, then we can see that we have a list of the 5 strongest spurs here. We can show some statistical data, like the RMS jitter, the residual PM and FM values, and the integral phase noise. All of this is computed over a selected range, offset range. And we can also scale the axes, rename them, and select the spur unit. Okay, so now let's go down to those tabs here. We have the measurement tab. We worked in this so far. In the time domain tab, we can see the current time plot of the detected signal on both channels. We can also have a list of all the measurement itself, but we need to select the trace for that. So for instance, we can select this, or we can select both traces. Then we see the frequency and the values at those frequencies. We can also go to the statistics tab to have the statistical values again, but additionally we can look at the Allen deviation plot as well as the RMS jitter plot, which shows us the RMS jitter versus the offset range that we select. Then we have a DOT info tab, which shows us the monitored frequency and power of the detected signal, and also gives us some options to show at the internal tune voltages, which are currently free floating. This basically has some monitoring purposes And then we have the measurement status tab, which gives us some information about the measurement itself. It also gives us information if something went wrong with the measurement. Now let's go back to the measurement tab. We might want to export this data to work with it in another program. So we can go to Save Traces. We have several options to export. We can export it into a MATLAB file or an Excel worksheet, into a text file with comma-separated values, or with the internal binary APPH plot data format file. So let's just select an image, PNG, and save it on the desktop here. So we can look at it, and you can see that it just shows us the currently selected plot. We can also save it as a PDF report. Let's just overwrite this one at the desktop and look at it. It gives us first the plot itself with some information about the selected duty. Then we have some statistical information again with the Allen deviation and the RMS jitter. Also a list of markers and the spurs that are detected. And also a table for the values of the measurement itself. Okay, that's already it. It's very easy, as you can see, to just set up the whole system. And thank you for your attention. I hope you enjoyed this tutorial, and have a nice day.